I'm a senior scientist at the Wrigley Institute. My background is in biological oceanography, and I'm involved in a project that is exploring kelp as a potential source of biofuel. I think there's been an interest in kelp and really marine biomass in general as a source of bioenergy because it takes very few natural resources to grow, right? You don't need fresh water, you don't need land, you don't need fertilizer, you're utilizing nutrients that are abundant in the deep ocean. So there's that aspect. There's also the fact that it's one of the fastest growing organisms on the planet. And because kelp grows in water, right, unlike its terrestrial counterparts, they don't have to fight gravity. And so they lack, the complex molecular structures that land plants need. And so they're easier to break down essentially for making different types of fuel, not just jet fuel. So those are a few reasons why kelp is so appealing. We have a really good handle on the life cycle of kelp. We know how to grow kelp in the nursery, in the lab, from reproductive material. It's fascinating because they actually start off as a little spore that's no larger than a large bacterium. And then they grow up to be these giant structures, right? They're referred to as the sequoias of the sea. And so they have this really fascinating life cycle. We have a really good handle on it, and we can grow it. Not only can we grow it, we can actually establish a seed bank that selects for certain traits that would be desirable for bioenergy or for food or for what, there's tons of uses for seaweed. Well, we're working on something that has been a bottleneck for the kelp to jet fuel pipeline. This bottleneck is something that people have tried to tackle since the 70s, at least documented reports. And the Department of Energy recently released about $22 million for people to pick that back up and continue the work. And that bottleneck has been the inability to produce enough biomass. For meeting energy demands, for making it cost competitive, but also, you need an uninterrupted supply, right? Year-round supply. And, it's been hard to attain. And what we're doing as part of our project is testing a method that would essentially eliminate that bottleneck, right? Where you could farm kelp year-round, large scale, utilizing a space that we have plenty of. Right, the U.S. has the largest exclusive economic zone in the world. This is ocean territory that spans 200 miles past our coastline. And so if we can figure out how to scale up the production, the downstream pipeline of all of this is fairly well established. You can take that wet biomass using various processes. You can make ethanol, you can make methane, you can make jet fuel, or you can use a process that will create a few of those things actually simultaneously. And the biocrude, one of the most I think promising sources is biocrude that you can make from kelp that can be fed into existing refineries. And so you don't need new technology and infrastructure. The oil that you get from kelp can be pumped directly into cars that exist today. Or you can break it down to even a simpler molecule like methane, which is one carbon, and produce and feed into the natural gas pipeline. So, it's breaking down the building blocks that are already there. Well, we completed a trial that established the feasibility of this method, the strategy that that takes kelp down into nutrient-rich deep water and brings them back up to near the surface where they can access light. That is something that has never been tested before. And so we really weren't sure how the kelp would respond, but turns out they do just fine. And they actually grew faster than kelp that we outplanted at a native kelp bed. So that was really exciting. Now we're really, thinking about how to tweak some parameters. You can play with the biology, like selecting for certain traits. You can play with the technical aspects of, well, how often do you depth cycle, how deep do you go, and that sort of thing, to really try and maximize your yield. So we're really trying to fine tune that. And then while we're focused on that, our partners at Marine Bioenergy are developing a model open ocean farm that utilizes autonomous drones that pull kelp arrays through the ocean. These are untethered structures, so they can move side to side, up and down, avoid storms, avoid ship traffic, etc. So they're building that scale, and also working with the Department of Energy to develop an economic analysis to see, what it's going to take really to make this commercially viable. Well, so the carbon, you're going to have some loss. So when kelp are taking up carbon dioxide, some of that gets built into more kelp. Some of that is lost through dissolved organic matter. But whatever gets put into more biomass, the biocrude that you end up with is a fraction of the carbon that you start with in the kelp. Because some of that also becomes methane gas. Some of that also becomes like a char, like a waste product. So you're absolutely right that it's not a one-to-one conversion, but it certainly is a more carbon neutral, close to carbon neutral source of energy than digging things up that took tens and hundreds of millions of years to form. I think solar is going to be a big part, and wind is going to be a big part, but for those things that require long modes of transportation, planes, trucks, and that sort, part of what has to be a diverse portfolio of alternative energy options. This can fill in for what we have until we have something better. And I will say, there are parts of this pipeline that are very energy intensive. So that part where you're converting the biomass into the energy products, if you're using like a high pressure, high temperature chamber, that's a lot of energy. So it's not, the whole pipeline itself is not carbon neutral, but kelp oil is still far better than an Arctic drilling platform. If it all works out, we transform the energy landscape, but I will tell you that the science and technology aspects are going to be the easy parts to all of this. We really need the government support, policy and programs, funding, as well as, societal buy-in and some pressure on our policymakers to do this. The problem for a long time was that no, federal agency was really taking the lead on aquaculture, and NOAA has really stepped in to fill that role now. And they're, providing the scientific expertise and the data to, not just help identify appropriate sites, but, building in funding channels to support academic and industry partnerships and so forth. And they actually identified Southern California as an aquaculture opportunity area, one of two. So that is, that is a big win for us here. But, more of that has to happen in order for this to really be successful. We've seen extraordinary things happen during the Industrial Revolution, during the Green Revolution. This is the next revolution. But we need buy-in from more than just the science and technology sectors.